So hello and welcome back. So in this video I would like to talk about the exponential growth and decay. Of course most probably we're going to, I don't know if I have talked about this based on the book curriculum or not, or if I haven't, most probably we will talk about it more formally in the book as well. But since this was in my notes, I thought I would simply just talk about it. So basically, let's have two examples. For example, if your f of x, let's suppose that f of x is equal to 3 times 2 raised to the power x, and g of x is equal to 3 times half raised to the power x. So if you take a look at this function, you can see that basically you could go from 0. For example, f of 0 here is equal to 2 raised to the power 0 is equal to 1. So 1 times 3 is equal to 3. F of 1 is 2 raised to the power 1 is equal to 2. 2 times 3 is equal to 6. F of 2 is equal to 2 squared is 4. 4 into 3 is equal to 12. F of 3 is equal to 2 cubed is equal to 8. 8 into 3 is 24. And you can see that this is basically all, 3, 6, 12, and 24. So the function is increasing as I'm increasing my inputs. So this is basically an exponential growth, and the graph of the function basically becomes something like this. So from 1 to 0 starts from 3 and then goes to 6 and 12 and so it's something like this. So this is an exponential growth. So here you need to pay attention to this number 2 here. But here, if I again start from, for example, g of 0, I get 0 half raised to the power 0 is equal to 1, so my output is going to be 3. So this function again starts at 3 because the initial point of the, what did we call it yesterday? The initial point or something, I don't know. But both of them start at y is equal to 3 because you have this initial point here. Or I don't remember that term. So g of 0 is equal to 3. G of 1 becomes 3 halves. G of 2 becomes so this becomes 1/4, and so this becomes 3/4. G of 3 becomes half raised to the third power becomes 1/8, so 3/8. So you can see that the denominator is getting bigger and bigger, so that the whole ratio or the whole fraction is getting smaller and smaller. So this whole function, the output is decreasing as I'm increasing the output, the input. As I'm increasing the input, the output is decreasing and decreasing. So this is an exponential decay. They call it decay. And so the function is going to be something like this. So if it is your x and y axes, so the function starts at 3, and then at 1 it becomes 3 halves, at 2 it becomes 3/4, and so on and so. So it's basically something like this. So this is an exponential growth, this is an exponential decay, And again here you need to pay attention to this half. So whenever, and this is basically nothing but your b, and this is again your b, and this is your a, and this is again your a. So when b is greater than 1, so here you have 2, the value is 2, so when b is greater than 1, you always have an exponential growth, and when b is, of course, is less than 1, you have an exponential decay. And you know that, I don't know if I've talked about this before or not, but b is not supposed to be cannot be a negative number. So how do we write that in mathematics, in a mathematical term? So basically b is supposed to be because you know that the problem is that b is always positive, greater than, or it cannot be equal to 0. It can be equal to 0, but it cannot be, b is greater than 0. It cannot be a negative number, because if you had a negative number as b, you would have a function like this. So let's suppose that we had f of x is equal to 3 times, for example, negative 2 raised to the power x. So here if your x is 0, this becomes 1, and so f of 0 becomes 3. And f of 1 becomes what? Becomes negative 2 raised to the first power is negative 2, and this becomes negative 6. And f of 2 becomes 4, and then 4 into 3 is equal to 12. F of 3 becomes, so this is negative 8, so negative 24. So it becomes a function, basically something like this. It becomes something like a weird function. So at 0 you're at 3, at 1 you're at negative 6. So this is something around here. At 2 you're at 12. So this is 1, this is 2, so you go all the way somewhere up here. And at 3 you're at negative 24, something way down here. So it's not even a continuous function. It gives you all of these points in your coordinate system. And so basically you will not get an exponential function in the first place. So b is supposed to be greater than 0. That's all about exponential growth and decay. Of course, I think we will talk about this in more formal terms in the coming videos, I suppose. I hope so. It must be somewhere in the book, most probably. And of course, doing the graph of exponential growth and decay is just like doing the graph of exponential functions. You have your starting point, your y-intercept basically, and then you need to input other inputs and then see where your graph goes, and then just draw the graph of the function. So that's all about exponential growth and decay. We will have some problems related to these functions. I'll see you in the next video.